In this video, you will learn what's happening inside a neural network when it's analyzing pathology images. Hi, I'm Alexandra Żuraw and I'm here to help you do better digital pathology. So if this is what you're after, be sure to subscribe, click the bell below, and be notified every time I release a new video. This video is from a webinar I gave for Davis-Thompson Foundation. The webinar was part of a one-day event, a paid event. And when I was learning about neural networks for tissue image analysis, at the very beginning, I saw the graph, I saw the visualization of it, I learned about convolution, but it didn't really click till I took part in a course given by Chen Sagiv. Chen Sagiv every year organizes a course about artificial intelligence for pathologists, and I think I'm going to join it again. That's going to be the third time. She's amazing. She was also a guest on my podcast, so be sure to check this in the description below. But let's dive into what is actually happening in a neural net.
What happens inside a neural network? These are different neural network architectures that all have a couple of things in common. First of all, they have dots, different colors. Usually on the left, they have yellow dots, and on the right, they have those orange dots, most of them. Then they have the lines crossing from one dot to another, and sometimes they cross more than in others. And they have this little guy, the perceptron, is a common element. There are common elements for different neural networks, but there are different architectures to tackle different problems in computer vision. And we're going to talk about it later. So, anatomy of a neural network. On the left, so neural network. Why is it called neural networks? Because those dots are called neurons. And those neurons, everything in this is a mathematical operation. This is just a visual representation how those mathematical operations are happening. But basically, what is happening within, we have the input layer where we put the data in, so put our annotations in, and we have the output layer where something comes out. It can be a classification, it can be segmentation, it can be one of the different computer vision tasks. So we feed something in, and then we get something that we want out. And there are things happening in between. It is called deep neural networks because it has many layers. Between the input layer and the output layer, we have so-called hidden layers. And they're called hidden because we don't see what's going on there. And that was also one of the concerns somebody wrote in the chat that, oh, we have this black box. We don't know what's happening there. And that's true. There are mathematical operations happening that we can later try to derive what happened, but we don't see it. It's not being shown to us while it's happening. And there are those lines between the neurons. And these connections are weights. And weights are the strengths of the connections between the neurons. And those neurons look for features. So look for characteristics of an image, the ones that a person is not putting in anymore. They are looking for this. And they are looking for this, adjusting the strengths of those connections, adjusting the weights. And if the connection between one neuron and the other one is strong enough, the other neuron gets activated. And this is activation function because the information doesn't just flow from the left to the right. And you can see that on the left, we have more dots than on the right. So it does not just flow from one end to the other. There is reduction of information, and I'm going to talk about it in a second, happening. But basically, this network, what it's doing, it's comparing the input to the output and the input that we have given it, the labels, and checking if the output makes sense and adjusting the strengths of the connections of different features of those neurons. And the training consists in adjusting those weights. So finding the best features to come from an input to an output, from the picture of the cartilage or picture of the car to the classification, this is a car. And those weights are being adjusted. At the beginning, it's random, and then they are being adjusted to give something meaningful. And how is it happening? There is a forward propagation of information from the image, from the native image, to the output layer. And then the output layer is back propagating this information, so moving the information back to compare to what we have given it. And if the comparison is bad, then the weights get adjusted. And if it's good, then the weights stay as they are. And this error, the measure of error between our annotations and what it is producing, is called loss function. And we want to minimize this loss function. We want to have it as small as possible. And that's what's happening in a neural network. And we saw many architectures. And one of the architectures that has outperformed other architectures in image processing, in computer vision, is a convolutional neural network. And this convolutional neural network also has this architecture that I just shown. But there are two things happening in this network that bring us from the left, the input, the native image, to the right, which is the mask. In this case, the pink is our cartilage and the blue is our rest, non-cartilage. So and what is happening there? Obviously convolutions, because it's called convolutional neural network, and subsampling. And I want to show you what that is, because you can learn the name by heart. But convolution is, again, a mathematical operation of, you can see on those squares that we're taking smaller square and projecting it to even a smaller and a smaller. And then this layer is fully connected. So all the neurons are connected. Here, not all the neurons are connected, which is okay because we're mapping the features from the native image into our output. And these images on the left and on the right, they correspond to each other, but the one on the left has a lot more information than the one on the right. The one on the right, the information is binary, it's pink and blue, and corresponds to something meaningful in the left image. And this is happening, so this reduction of information, this squeezing of information is happening through convolutions and subsampling. And convolutions means applying filters. So this square is a filter that you apply, and you look for something that this filter can recognize. And then you map it, but you also do at the same time subsampling, meaning you squeeze this information, because otherwise your input is going to be as big as the output, and you only want classification for a limited number of classes. So let's look at how convolution looks like. So we take on the right side, the dark square, we are scanning the big blue one with the smaller dark one, and extracting and squeezing the information to produce those little white ones. And this is what is happening in a convolutional neural network, to filter the information and squeeze it, and filter and squeeze it, and filter and squeeze it, and then at some point we have our output.
You stay till the end, it means you are truly a digital pathology trailblazer. Or maybe you just wanted to learn about neural nets. Either is fantastic, and thank you very much. Be sure to check the resources for this video, a podcast with Chen Sagiv, the full webinar, or the playlist, whichever is best for you. And I talk to you in the next episode.